Hi everybody. This video will go over section 5.1 or section 1 of chapter 5, exponents. In this video we'll talk about how to simplify exponents using the properties of integer exponents. Basically it's a collection of rules. And then we'll talk about how to recognize which property to use in certain situations. So let's go ahead and get started. Now let's suppose that we have a non-zero number called a. And let's suppose that we have a raised to a certain integer power called m times a raised to another integer power called n. Well, then it turns out that the product is the base a raised to the m plus nth power. As an example, because I know that sounds kind of weird. Suppose that I have 2 cubed times 2 to the 4th power. Well, remember, 2 cubed is basically just 2 multiplied by itself 3 times. 2 times 2 times 2. And 2 to the 4th is 2 multiplied by itself 4 times. 2 times 2 times 2 times 2. And notice that we have 2 multiplied by itself 1, 2, 3, 4, 5, 6, 7 times. So this would be equal to 2 to the 7th. Well, notice that 7 is equal to 3 plus 4. So this could be written as 2 to the 3 plus 4. So this gives you an idea of where this little rule comes from. Now we also have a little nomenclature here. It turns out that we call the number a, or in this case 2, the base. And when we start talking about logarithms and inverse logarithms, that will become important. And of course, then the integers m and n are exponents. And notice that when we multiply them together, we are keeping the exact same base. The base never changes, just kind of like when you add fractions, the denominator never changes. But we go ahead and we add the exponents. Okay, so let's see how this works. We're going to go through a lot of examples. And here's the first one. We have x squared times x to the 4th. Well, using the product rule, that's going to be equal to x to the 2 plus 4, which will be equal to x to the 6th. Now here we have y times 6 times y. Here we have y times 6 times y to the negative 2nd. And even though it's a negative power, it's still an integer exponent, so the rule still applies. This will be equal to y to the 6th plus negative 2. Well, no, that's just y to the negative. That's just y to the 6 minus 2, which is equal to y to the 4th. Okay, now here we have 4 squared plus 4, which is just 4 to the 2 plus 1, which is equal to 4 cubed. Of course, now since we have a number here, we can actually evaluate that, and that would be 64. Another way to look at that, this is that 4 squared is 16 times 4 is equal to 64. Two cubed plus 2 squared, well, once again, that will be 2 to the 3 plus 2 power, which will be 2 to the 5th, which actually is 32. And then finally for this section, we have negative 2 to the 4th times negative 2 cubed. That will be negative 2 to the 4 plus 3. Now here, notice that here the base is negative 2. That'll be negative 2 to the 7th, which will be equal to negative 128. How does that work? Well, here's negative 2 multiplied by itself 7 times. 1, 2, 3, 4, 5, 6, 7. Now negative 2 times negative 2, well, that's just positive 4. Positive 4 times negative 2, that is negative 8. Negative 8 times negative 2 is positive 16. 16 times negative 2, that's negative 34. Negative 32, my apologies. Negative 32 times negative 2 is positive 64. And then finally, 64 times negative 2 is negative 128. So whenever you multiply a negative number by an odd power, you will get a negative number. And whenever you multiply a negative number by an even power, you will get a positive number. And we'll talk about that more in some detail. Okay, now we are going to talk about how to multiply terms with other stuff in there, like coefficients. Now here we have 2y squared times 3 times y to the 9th power. And basically what we'll do is you're going to do the coefficients separately, and then we are going to do the base separately. So we have 2 times 3 for the coefficients. And then over here we will have y squared times y to the 9th. And then 2 times 3 is 6. We can use the product rule for this. That'll give us y to the 2 plus 9. And that will give us 6y to the 11th. For the next one, we have negative 3x cubed times negative 4x cubed. And we're going to do this the exact same way. We're going to multiply the coefficients together. Negative 3 times negative 4. And then we're going to do the bases together. And that will be x cubed times x cubed. Negative 3 times 4 is positive 12. And then the product rule here is x to the 3 plus 3, which is equal to 12x to the 6th. And here we have, now here we have two bases, so we need to treat each base separately. So here we have negative 36 times 8. Then we have a times a, and then b squared times b to the 5th. Well, it turns out that negative 36 times 8 is negative 288. Then we have a to the 1 plus 1 power using the product rule. And then we have times b to the 2 plus 5th rule, or 2 plus 5 power, and that will give us negative 288 a squared b to the 7th. Now let's talk about the exponent 0. Now suppose that I actually had the product of 2 to the 2nd power times 2 to the negative 2nd power. Well, that would be equal to 2 times 0. Also, it turns out that 2 to the 2nd power times 2 to the negative 2nd power is actually equal to 2 to the 2nd power times 1 over 2 to the 2nd power. And that would be, and here we have basically 2 squared, which is 4, divided by 4. These would cancel, and we would have 1. So what does that tell you? That tells you that 2 to the 0 is going to be equal to 1, or any non-zero number raised to the 0th power will be equal to 1, because you can replace 2 with any a, and it'll be fine. With the sole exception of 0, because if you had 0 squared times 0 to the negative 2nd power, that would be 0 times 1 over 0 times 0. And this right here is undefined. And as a consequence, 0 to the 0th power is undefined, which of course is set again right there. And an example is, of course, 2 to the 0 times negative 2 to the 0 times negative 2 squared. Well, this term right here will be equal to 1 times negative 2 squared. Negative 2 times 2 is 4. This would be equal to 4. Okay, and notice, remember in the product rule, we were actually, when product rule, which is multiplication, we were adding the exponents. So it kind of makes sense that in the quotient rule, where we're dividing, we are going to subtract the exponents. So that is indeed the case. If we have a non-zero, if a is a non-zero real number, then a to the mth power divided by a to the nth power is going to be equal to a to the m minus n. So in this case, instead of adding, we subtract. As an example, here is 4 squared over 4. That can be rewritten as 4 to the 2nd power minus 4 to the 1st power, which is 2 minus 1 is just 1, or just simply 4. And let's do our first example, and here it is. Again, using the quotient rule, we are going to have x to the 6th minus 1, which is x to the 5th. For the next one, we have y to the 8th power over y squared. That will be equal to y to the 8 over minus 2, which is y to the 6th. And then finally, here we have, using the quotient rule, x to the 6 minus 6, which is equal to x to the 0, which is 1. And of course you can deduce that because we have the exact same quantity here in the numerator that we do in the denominator, which will actually make that go to, once again, 1. Okay, well, let's talk about the case when we have other stuff such as coefficients in here, which adds a slight degree of complexity. Well, we handle this the exact same way that we handled it in the product rule. We treat the coefficients separately. We treat the coefficients and the bases separately. So here, for the coefficients, we have 15 divided by 3. Over here, we have x to the 15th power divided by x squared. 15 divided by 3 is 5. And then we're used the quotient rule here, and that will give us x to the 15 minus 2 power, which will give us 5x to the 13. For our next one, we have two bases, and we need to treat the coefficients and each base separately. So this will have 20 divided by 2 times x to the 10 divided by x squared times y to the 6 divided by y cubed. And that will give us 20 divided by 10 is, 20 divided by 2 is 10. This will be using the quotient rule, x to the 10 minus 2, and using the quotient rule here, we will have y to the 6 minus 3, and that will give us 10 x to the 8th y cubed. Okay, now every now and then you will encounter a negative exponent. And here's the really cool thing about negative exponents. Basically, to get a positive exponent, you just take the reciprocal. So, as we mentioned before when we were talking about the exponent 0, 2 to the negative 2 is just 1 over 2 squared. Or 1 over 2 to the negative 2 is equal to just 1 over that, which would be 2 squared. It's this rule right here. A to the negative nth power is nothing more than 1 over a. Now, in mathematics, we have some rules when we are simplifying exponents. Okay, and here's one of them. All of our exponents should contain, all of our expressions should contain only positive exponents. So we don't want to see anything like this. This is bad. We don't want to see that. Okay, we want to see this instead. Secondly, we want each base to appear at most once. We should never have an a twice or an x twice. All the bases should appear only once at most. Unless, of course, they cancel, then they shouldn't appear at all. So let's see how that works with a problem. Okay, well, this is a pretty straightforward problem. We are going to use the rule for negative exponents and positive exponents to simplify each expression. And we would simplify this by rewriting this as 1 over 5 to the first power, which of course is just 1 over 5. You could take it one step further and write it as 0.2. Either of these would be fine. Okay, what about x to the negative cube power? Well, once again, we can't, this is bad, can't have negative exponents, so we can rewrite this as 1 over x cubed, and well, at least you may not be happy, but I'll be happy. And then here we have x to the negative 9th power times x7. Now to solve this one, we would need to use the product rule. And that would be x to the negative 9 plus 7, which will be equal to negative 9 plus 7 is x to the negative 2. Well, we have a negative power here. We can't have that, so we will write this as 1 over x squared, and then everybody's happy. Or most importantly, I'm happy. Okay, for my last set of examples, let's take a look at this one. Here we're going to actually combine rules for exponents. Now this one is pretty straightforward. We only need to use the product rule. So this will be 2 to the negative 5 plus 8 power Negative 5 plus 8 is just 3, so this will be 2 to the third power, which will be 8. So that one was pretty straightforward. So we can find something a little more challenging. Well, this would use the quotient rule, but notice that we have a negative number down here. So this would be equal to x to the 6 minus a negative 1, which would be equal to x to the 6 plus 1, which is basically x to the 7th. And now we have 10 to the negative 5th divided by 10 squared. Once again, using the quotient rule, we can write that as 10 to the negative 5 minus negative 2. That will be equal to 10 to the negative 5 plus 2, which will be equal to 10 to the negative 3. So we can rewrite that as 1 over 10 cubed. We could also write this as 1 over 1,000, or we can write this as 0.001. Both of them are the exact same quantities and considered simplified. And here we go. This one will require a couple of rules. Notice that we have coefficients here, and then we also have some bases. So we want to treat the coefficients separately. That will be 15 divided by 3. Then we have x to the 10th. Oh, I forgot, I didn't see the 2 there. So this will actually be 30 divided by 3. 30 divided by 3. Then we will have x to the 10th times x squared divided by x to the 15th. Okay, so maybe we should do the product rule first to take care of the numerator. And we can also evaluate the 30 divided by 3. That will be 10. This will be x to the 10 plus 2 divided by x to the 15. That will be 10 times x to the 10 plus 2 is just x to the 12th divided by x to the 15th. Okay, well now this we can use the quotient rule for. That will be 10 times x to the 12 minus 15 power, which will be 10x to the negative cubed. And now we need to deal with our negative exponent. We can do that by moving that to the denominator, and that will be 10 over x cubed. And that is all I have for this particular class, or this particular section. Here is a summary of all the exponent rules that we just did, written out in nice convenient table form. Okay, well, I almost forgot to do this, but I remembered, so let's go ahead and check out a few of the problems you might encounter in this section. Well, here's the first one. It is x to the 6th power times x to the minus 3. And this is an application of the product rule. So we have x to the 6th times x to the minus 3. That will be equal to x to the 6th plus minus 3, or x to the 6th minus 3, which of course becomes x cubed. But I include the equal sign there. So let's see what we get here. So to type this in, I can type in x, a hat for the power sign, cubed, and I hope I'm right. And I am. So that's one set of problems that you will see in this particular assignment. This one has negative 3 to the 0th, so let's go ahead and look at this one. This one is negative 3 to the 4th times negative 3 to the 0th power. Once again, any non-zero number raised to the 0th power is 1, so this really just is negative 3 to the 4th, which would be negative 3 times negative 3 times negative 3, times negative 3. This will be negative 3 times negative 3 is positive 9. Negative 3 times negative 3 here is also positive 9. And this would be 81. So our answer should be positive 81. And it is. Okay, this is an example of the quotient rule. So here we have x to the 8th divided by x. Using the quotient rule, we would write this as x to the 8 minus 1, which would be x to the 7th. Okay, that is just a similar problem as before, so we'll go ahead and skip that. Okay, here's one with a negative exponent. And as remember, if it has a negative exponent, then we can rewrite it as an expression with a positive exponent by looking at the reciprocal. And the reciprocal of x is 1 over x, and that we can raise to the 7th power. So let's put that in. 1 x to the 7th. And there we go. Okay, this is one that I talked about in class, and let's talk about it here because it is a sneaky little problem. But this is basically 2x to the 0 minus 3y to the 0. And we want to evaluate the exponents first. So x to the 0 is just 1. So we have 2 times 1, or 2. Y to the 0 is just 1. So 3 times 1 is just 3. So that'd be 2 minus 3, which is negative 1. So we come over here, put negative 1 in, and boom, we are correct. Okay, so this one is just a little more complicated. Here we have 3xy to the minus 4th times negative 8xy squared. All right, so you want to treat each base separately, or we want to treat each base and all the coefficients separately. So we are going to have 3 times negative 8, and then we're going to have x times x, and then we will have y to the negative 4th times y squared. Now 3 times negative 8 is negative 24. X times x is just x squared, and then this is going to be y to the negative 4 plus 2, which is y to the minus 2 power. Of course, we can't have a negative exponent, so we would need to bring this down to the denominator, and that will give us 24 x squared divided by y squared. And there it is. Oh no, actually our second to last problem, which is negative 4 to the 4th power. That will be equal to negative 4 times negative 4 times negative 4 times negative 4. That will be equal to 16 times 16, which will be equal to 256. Oh, 83 there by mistake. I didn't want that. Much better. And okay, well, just for kicks, let's go ahead and do the last problem. Last problem is negative 4x to the 5th divided by negative 2x cubed. Well, first we want to deal with the negative 4 divided by the negative 2, and then we have x to the 5th divided by x cubed. That will give us 2x to the 5 minus 3, or 2x squared. And there you have it. And that is all I have for this lesson. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.